So this question 7.69 basically is asking you to draw the mechanism for the problems that are there. So it gives you for A this. You have an alcohol. Remember, alcohols are terrible leaving groups, so we want to protonate them first. So I'm going to use concentrated sulfuric acid to do the protonation. Remember, that comes with some water. The water is going to be the base in the end. And this is an alkene. So I'm doing an elimination. So this is tertiary. I'm using an acid, so that means it's E1. Acids only do E1 because they come with weak bases, and we have our heat. So our first step is protonation. So I protonate that alcohol. It makes it a much better leaving group because when it leaves as water. Water is pretty stable. So the leaving group leaves. Remember, this is going to be E1. We get our tertiary carbocation, and because we have heat, we can deprotonate one of the beta hydrogens. Remember, there's 2 beta positions, but they're equivalent to each other. So then our water, and it's water that comes in and deprotonates, and you get that. So that's how you draw that mechanism. So B is going to be very similar, except you're going to get rearrangement. So we get our acid. We do our deprotonation of the acid, or protonation of the alcohol, whatever you want to call it. Again, it has the same conditions as the previous one. So we have a good leaving group. Leaving group leaves first. Okay, that's our highest energy step. It's our rate determining step. This is the highest step that we'll get. And then we get this thing. And then we can do a rearrangement with an alkyl shift over. Specifically, this is a methyl shift. And so we get our carbocation on this side. And then now we can do an elimination using our water. Right, we don't use the sulfate because sulfate's not a base. Do an elimination, and I get this product. So that's the product that they said. The question C said that we draw this alkyl halide, and it uses ethanol. And so ethanol is going to be both our base and our solvent in this case. And even though it doesn't say heat, there should be some heat there. If there's no heat, it will go E1. All right, so our first step is the leaving group leaves first. We get our tertiary carbocation, and then our base, which is going to be the ethanol, will come in and deprotonate in these conditions. You get that. All right, and then the last question for this is same question, except we're using a base that is a strong base. And so since our base in this case is ethoxide ion, the sodium is just a spectator. And in this case, ethanol is just our, so this was E1. This is going to end up being E2 because I have a strong base. It still gives me the same product. Now it would give me, this is the Zaitsev product. It would give me the Hofmann product if I use a much larger base. So our first thing that we're going to do is I'm just going to redraw this. And I'm going to just draw in one of the beta hydrogens, your ethoxide, which is your base. Remember, the sodium is a spectator, so don't do anything with it. So your base will deprotonate that hydrogen, form a double bond, and kick the leaving group at the same time because this is E2.